Hey everybody, welcome to PC Perspective. We are here today just a few days after the launch of a brand new microprocessor from Intel, the Core i7-4000 series, I guess, Haswell codenamed architecture. And we are going to talk about Haswell architecture, we're going to talk about Z87 chipset, we're going to talk about specifically ASUS Z87 motherboards, and there are a lot of them. And there are a lot of features that we're going to talk about. And joining us today is JJ from ASUS. Hey JJ, how are you?
I'm doing all right, thank you for asking.
If you guys remember, I think Z77 lineup, JJ was here.
Yes.
We did some demos. It'll be a similar vein here. We're going to break it up into a couple different segments. We're going to talk about product segmentation. We're going to talk about the lineup. We're going to talk about AI Suite 3, kind of software-based overclocking. We're going to go to EFI overclocking. We've got a lot of stuff we're going to go over. And then we're going to touch ROG. We're going to give away prizes. Yeah. We've got some motherboards. We've got a graphics card we're going to give out. So pay attention, stay tuned, and we will definitely address all of that as we go. Now, the first thing I want to start out with is, just in case people are signing in last minute, is to realize that Intel launched a new processor. And with that comes a bunch of new motherboards. So at PCPro.com, if you go there, you'll see my review of the Core i7-4770K, which is the highest-end flagship Haswell processor that was released technically on Saturday, I guess. And it went on sale Saturday and Sunday as well. So it was a hard launch for all that kind of stuff. It's a new socket. It's 1150, LGA 1150, which means new chipsets, new motherboards, not compatible with the Z77 or anything prior to that. And Sandy Bridge and Ivy Bridge processors aren't forwards compatible with Z87 products either. So I posted the review. We looked at Haswell. We're going to talk a little bit about Haswell real quick. I mean, it's a very similar architecture to what Sandy Bridge was and Ivy Bridge is. Most of the changes were on the graphics side.
I think also it's, I think storage, though, is probably a pretty big update change, right, in terms of the chipset relative to the CPU platform, because you got to have both, right? So, and this generation, I mean, I think the addition of going on to a significant increase in the SATA sub-storage connectivity, as well as an improvement on the USB, those are always definite things that are people interested in.
So you went from 2 SATA 6G ports to 6 SATA 6G ports, courtesy of the chipset itself. And then up to 6 USB 3.0 ports, right?
Yeah, correct. The up to 6 is important because while technically it can allow for up to 6, there is the flexible I/O specification aspect of it, which adds some variability into how certain things are mapped depending on the motherboard design and things along those lines. But I think that you're right, though, in terms of saying overall it's going to feel pretty similar, I think, for all intents and purposes to the previous generation platforms, whether we're talking about Sandy Bridge or Ivy Bridge.
Right.
But I think from our perspective, though, there's that really big change in terms of that fiber, right, that IVR being incorporated inside the CPU. And for this generation, it definitely does affect quite a bit of variables in terms of how you work with the board. Not necessarily from the perspective that, hey, all of a sudden there's going to be all kinds of new things that you don't understand are going to necessarily be new to you if you've been working with the platforms for a couple of generations.
Yes.
But inherently on how you work with the platform, I think has changed a bit because of the integration of this fiber. And I think there's also...
Fiber, which, by the way,
yeah,
fully integrated voltage regulator.
Yeah. Yep.
Right. So this is something that Intel moved from board design onto the silicon of the chip, which is instead of sending 4 different voltages into the processor, essentially you're sending 1 as a motherboard vendor. And then internally, it divides up the power between the CPU cores, the memory, the ring bus, those types of things, the graphics. Yeah. Right. So it handles all that internally, which I think many people see it as kind of took away some of the differentiation ability that you guys had as a motherboard vendor.
I mean, to an extent, I think it really actually depends on the motherboard vendor that exists out there. I mean, for one, it's actually interesting because in this design, you can really tell that Intel's direction and focus at wanting to have this technology and this architecture be present across so many different product segmentations, whether it's mobile products or whether it's desktop products. It definitely has that vibe because, for us, we'd already been using a digital PWM or controller on the motherboard for a lot of generations. So a lot of the inherent advantages of what this fiber would bring to the table are something that we had already been kind of working with for a long time. But for other companies that may have not integrated that in there, actually inadvertently they're improving their product because they're adding more functionality, more control, more aspects of adjustment, and better efficiency.
And we were talking earlier that that's really, on the desktop platform, that's not nearly as important as it is on the mobile platform. And what Intel was seeing was variance in how efficient their platforms are being integrated into laptops and ultrabooks, and maybe even into tablets. And they said, okay, we can fix this. We'll make it a standard thing where we control it, and that's what the integrated voltage regulator kind of solves. So it doesn't. It changes things on the motherboard side, on the desktop consumer side, but it doesn't really fix anything.
Yeah, no, it doesn't fix anything, and there's still, there's a lot of confusion between people what they understand to be something as the PWM and what gets largely encompassed as the VRM, right? So the power components that you still have on the motherboard. So if you were to pick up a board, maybe Ryan, to reference like the VRM power block section, right? Which for you guys that kind of keep conscientious of what a VRM is designed of, that's going to be things like your inductors or your chokes,
right.
The MOSFETs and the drivers and those capacitors. None of that is being integrated inside the CPU package.
Gotcha.
So the portion that people generally would be conscientious about as far as saying that this is now the part that's inside is a very, very small little chip that's usually like on the top corner of the board. It's the small little PWM. That's pretty much kind of what you integrated inside the CPU. So from a board design standpoint, it doesn't take away that we still have to bring a lot to the table in terms of how we lay out our trace work to be able to tune memory compatibility to ensure performance. We still have to put on good quality power componentry to make sure that you can actually provide the power for the CPU under various types of configurations. But like I said, I think that we probably definitely talk about overclocking and talking about how you can manage to tweak and tune your system for efficiency or performance. The Fiverr does bring some interesting things into play as far as how you work with the platform.
All right. Now, before we dive into the rest of we're going to talk about individual product segmentations. We'll get into overclocking. We'll get into all that kind of stuff. We are monitoring the chat room. If you're at pcper.com/live, we have a chat room there where we're keeping an eye on what your feedback is. If you go to pcper.com, just pcper.com right now, the top news post should be a reference to this live stream. Let me double check and make sure it's still up there. Yeah, it's called PCPer Live, ASUS Z87 live stream. And if you go there, there will be a form at the bottom of it that you fill out, and you go ahead and click through onto the full thing, and you fill out this form, and it will enter you in for one of our contests. You give us your name, your email address, and then you tell us about which ASUS product line is actually your favorite and why, giving some feedback to JJ in those regards, and you'll have a chance. What are we going to give away with that one? That's the Z87 Sabertooth?
That's correct, our Z87 Sabertooth motherboard.
Which is a very popular motherboard, I'm told.
Yeah, it's
the Sabertooth line.
It's an awesome series lineup, awesome series board.
So all you have to do to enter for that contest is go to pcper.com, click through to that news post. You will see a form at the bottom, ask for your name, email, and answer that short question. And at the end of the stream, which will be in a couple, 3 hours, we will draw that winner and email you and let you know. But you'll want to be watching the stream anyway because we have other prizes we're going to give away in real time.
Yeah, some very cool stuff. We got an ROG board, we got a mainstream series board, we even got a graphics card. Yeah,
we've got some good stuff. The last thing I'll say on just the processor in general is go to pcper.com, read my review of that. I will say that the from a desktop user's perspective, we're seeing anywhere from 5% to 15% performance improvements on CPU-bound applications,
depending
like
on
media
the
transcoding.
Instruction sets and things like that.
Yeah. So if you get into AVX2 capable software, which there isn't really much any out there yet, but SciSoft will run some AVX2. If you look at the SciSoft Sandra multimedia test, for example, it uses AVX2, and you can see a huge jump with Haswell over Ivy Bridge and Sandy Bridge E and all that kind of stuff. But it's something that's coming down the road. Integrated graphics performance is improved, still not quite as good as even Trinity, and as we all know, actually, Richland is for sale on Newegg as of today, so I can tell you that our review will be up on that later tonight, so you'll see where AMD stands in the world of integrated graphics and that kind of thing. So it's Haswell is an improvement. It's not a drastic leap up in CPU performance.
No, but like you said, it's an improvement, and I think it's relative, right? I mean, at the end of the day, Z87, it's a performance-oriented chipset. I think most of you guys that are going to be interested in working with it and building it, you're going to be running some variant of a discrete graphics card, but where the iGPU is definitely going to provide some strong capabilities is going to be in those everyday boxes. Maybe if you're going more value-oriented in terms of the type of build, or even if you're doing something media-centric, right? You've got full on-die decoding capabilities for a lot of high-definition video formats. So when you talk about being able to build, quality, small form factor solution, it's still going to have a lot of legs in terms of what you can do with it, and it's going to have great power efficiency to boot, right? So I think from a gaming proposition, necessarily, there could be improvements, especially compared to where we know the maximum performance capability of what Haswell has to offer is in the mobile segmentation, right? But on the desktop side, like you said, it's a fairly moderate improvement.
let's go ahead and dive into it.
Oh, wait, one last thing I did want to touch on. I always get question on people is with a new chipset launch, if there's other Intel chipsets that are out there, is, what's still the relevancy? And ultimately, like you said, you can find out about all of this if you guys check out, Ryan's review on the CPU and on the platform as a whole. But X79 isn't going anywhere. So if you're still interested in a platform that is ultimately going to have more flexibility in terms of the amount of PCIe lanes, of course, the more cache, the more cores, then X79 is still your your flagship enthusiast level platform, and that's not going to be changing anytime soon. So this is still ultimately a 4-core, 8-thread architecture.
No secret information on Ivy Bridgey or anything like that yet?
Nothing that I can discuss. All we can say is, at the end of the day, X79 is a mature platform. It's still great in terms of its performance and what it brings to the table, and it's not going to be going anywhere. So definitely for you guys.
It's interesting. If you look at our review, there are still some instances, like if you get up to the top end 3970X part, where it's beating Haswell, but there have been enough architectural improvements where a 4770K, which is
the IPC,
can beat a Sandy Bridgey 6-core 12-thread, because they're also running a little bit higher frequency, I guess, too. So, yeah. It's an interesting kind of set of options that the user has at this point. So we'll get into, if you guys have questions on any of that kind of stuff, we'll try to get JJ to answer what we can. And you never know. You never know. But I do have a list of questions here that we'll get to soon. But let's talk. Let's start out with kind of the ASUS mindset, right? So here, sitting in front of us on the table, we have 4 different motherboards. We have this red and black beast that is the Maximus 6 Extreme.
That's right.
We have the Z87 Sabertooth down here with the armor on it. Makes it stand out. And then we have, what is this, the Z87 Deluxe?
WS.
WS, this is WS, and then we have the Z87 Deluxe up here that sport new color schemes as well. So let's talk about the segmentation. Why have 4 different series of boards? Like, what's the mindset behind that?
Well, we've been offering now segmentation series for quite some time, right? We're not talking about this as a new introduction. I think that, we were probably the pioneers in really trying to break down different boards for different levels of usage. I think that we're inherently very conscious of the fact that the PC DIY kind of movement or initiative in itself is centered in choice, right? The person that decides to ultimately build their system, is interested in having flexibility, whether it's for aesthetics, whether it's for feature set, whether it's for the functionality, even for the form factor, right? There's all these type of variations that come into play to that, and it can be very difficult to ultimately try to define a product that fits perfect for every single type of usage scenario, right? Especially, as that we see within the do-it-yourself community, users like myself, users like you that have been doing this for a long time, you get passionate in different ways about it, right? Maybe you're somebody that's really avid into PC gaming, and so you're really interested in having enhanced levels of network connectivity or audio. You want more flexibility in terms of GPU expansion. You could also be somebody that likes building their system in terms of having cutting-edge technology support, whether it's things like, Thunderbolt or the latest generation wireless,
right.
Or you might just be a user that really wants stock level performance, right? You're not interested in overclocking, but you still want top quality, right? You still want maybe advanced monitoring capabilities. And so, when we think about all that, sure, could we probably make a motherboard that would have every single one of those things all on it at one single time? It's entirely possible. It's not to say that it wouldn't be possible,
right.
But it would probably be very complex, very expensive, and limiting ultimately, right? So I think our key mindset is that we're going to keep a set of non-negotiables, and I think we covered this to a pretty good degree in the previous generation video for Z77, but we kind of have a design philosophy to say, hey, there's going to be things that regardless of which segmentation board you buy, you're going to get inherent ASUS kind of design initiatives, whether it's going to be our power topology, whether it's going to be the compatibility, the UEFI parameters, whether they're going to be optimized technologies like Fan Expert 2, Intel NICs, USB 3 boost enhancements, and it's only going to then be that under each one of these segmentations, we're going to find tailor feature set that really is in line with that kind of specialized segmentation base. So whether you're a gamer, or you're a stock user, or content creation, because take for consideration a content creation user, right? They are going to have an appreciation for why they actually might want to run a Xeon part, because the Xeon part's going to give them the ability to do ECC-based memory support, right? Now, a normal user probably wouldn't run their system, 6, 8, 10, 14 hours plus consistently, right? where we're talking about the CPU could be pegged at 100% utilization, because maybe under that WS they're doing consistent rendering, they're doing transcoding, they're doing compute-based processing, right? So they need a guaranteed level of reliability.
Right.
Normal user, you know, maybe even if you're gaming, you game for 3, 4, maybe 5 hours, right? But then you're eventually going to walk away, you're going to go eat lunch, you're going to, you know, kick onto YouTube, you're going to switch on to, you know, Hulu, you're going to maybe jump into checking out some email, but your workload usage is entirely different, right? It's the same way that if, you know, you check out like a hard drive manufacturer, they have a SAS drive, they have, you know, a drive that's designed for 24-hour video operation, and then they have normal mechanical hard drives. And yes, could any one of those drives be used in the same way, you know, that let's say the standard hard drive is produced? Entirely so, right? But there's different levels of functionality and even validation, right? One has been designed and tested to run at 24 hours, and the other one, it's still a very reliable product. Could you probably even running it 24 hours? Yes, but there hasn't been necessarily that extensive level of validation or attention to the way that the product's been designed. So I think that what we've continued to notice is that the community keeps asking us and saying, hey, we want to see this and we want to do this. So that's what we've been able to do by having these four segmentations. And lastly, I think the other important part is that having flexibility, very similar like cars in different companies that sometimes position out higher tier products, you sometimes have the flexibility of designing very new and special features that you couldn't do it all under one family. So like ROG, when we take on a new feature set for ROG, it could require the dedicated resources of, you know, that, you know, 5 or 6 engineers on that R&D team just dedicating themselves to that new function or feature. And the rest of the design team could be focusing on all these other parts of the platform, and they don't have the bandwidth to allocate to that. And that's what makes us very special. A lot of the other companies that are out there, they just have one board division and one set of engineers to devote to everything. But you know, the tough team has their own dedicated team, the ROG team has its own dedicated team, the WS is their own dedicated team, and the mainstream series is their own dedicated team. So it really allows us to kind of keep a design ethos as a whole, that you're going to get kind of these non-negotiables across any ASUS board, whether, you know, it's stability, reliability, overclockability, or certain kind of core features. But at the same time, we can really go in, tap each out one of those communities and say, hey, what is it you guys want to keep seeing improved upon? And we can further upon that. Okay, so it's about choice, you know?
So if we look at these 4 different segments, what is kind of like the key user type that each of them targets?
Well, if we first look at, say, something like the Deluxe, right? So that's this board down here that we have. The Deluxe is representative of our mainstream series. So the mainstream series is kind of like the jack of all trades. It's really a board series that's designed for somebody that maybe is a veteran builder, has been building for years, or somebody that maybe it's the first time they decided to build. But what we really need to try to have it be is the best representation of what ASUS is as a motherboard vendor. So we want to have a lot of the key design features and functionality, rich connectivity and expansive, a lot of multimedia-oriented features, but it could be a gaming board, it could be for content creation, it could be for stock operation, it could be for pretty much anything you want, and we're trying to just fit the mold that, hey, if you're just looking for a great quality board, this is going to be the choice for you. It also tends to consistently offer, you know, the most, I'd say, rounded out feature set without going into targeted focus points of usage. So where, if, let's say we go over to ROG, right? ROG is now been in, you know, a part of our stable for over 5 years in terms of the motherboard division, and that's really
Has it been that long now?
Yeah.
All right.
It's been segmented specifically towards, you know, the gaming, the enthusiast audience. And what we mean by enthusiast is anybody that builds a PC is an enthusiast. But here we're talking about the guys and the girls that take that extra layer of appreciation. You know, they want to have more gears and switches in terms of tweaking and tuning their system. They really appreciate different aspects as far as overclocking. You know, they appreciate even the different styling and the aggressiveness that kind of the ROG products bring to the table, right?
Yeah.
And there's also definitely a level of innovation that we focus in on ROG. ROG is kind of like, you know, our skunk works, right? Or, you know, or that division from a company where you try to do stuff that's really unique and different every year, you know, where you have more flexibility to, let's say, let's try something that, you know, you might have not thought about before, and let's see if we can implement that. Because the people that are on here, you know, like I myself, I consider myself somebody that's on the bleeding edge, not on the cutting edge. I will upgrade my chipset every time there's a new chipset release, you know, whereas when we, when we consider something like Tough, those users, you know, they're generally more interested in talking about having their systems 3, 4, 5 years, right? ROG is about those guys that are looking for the best of the best, and, you know, there's also definitely that subset of even gaming focus where we're bringing advanced audio or networking or specialized features that really cater to that type of user base. For the WS segmentation, this kind of goes in a very special niche of users, which is continuing to evolve. I mean, right now we're doing all this video work, and you really need a platform that requires a large amount of expansiveness in terms of the connectivity and the type of reliability that it needs to take into place. And so the WS series boards are really catered towards people that are doing some form of content creation, production workflows, right? You could be talking on audio, you could be talking video,
right.
Photos, it could be compute-based support, right? And a large part of the WS is also going to be in the validation, right? That we're validating, Xeon ECC support, Xeon Phi, Tesla, Quadro-based support, Fire Pro. Even the fact that most of the WS solutions are going to always offer very expansive levels of PCIe connectivity, because you might maybe be running 3 HDMI capture cards and then a compute card and then maybe like a GPU to be running.
So that'll have like a PLX,
yeah,
PCI Express.
Not always. I mean, it depends, because like an example is we have a P9D board that we'll look at that's based off actually a different chipset that Intel launched for this platform also, the C200 series chipset.
Okay.
And that chipset actually has more PCI lanes than default the Z87 chipset. But it's still, that's one of the hallmarks, is that it still has more PCI expansion by default as part of that WS focus, right? You also have like things like dual NICs, which is very consistent on WS, because maybe you're running locally in terms of the internet, but then you're also running into an internal network, right, for rendering out or pushing out video. You could be sharing things across different workstations or NASs or SANs, things like that, right? And then moving lastly to the Sabertooth, or now the Tough series,
right.
This has generally been hallmarked by only one board. This generation, we've expanded upon it, of course, to actually two boards, a micro ATX SKU and an ATX-based SKU.
This is by far the most unique looking.
Sure, I think definitely, the thermal armor aspect adds a different visual element to it. But Tough actually came born from feedback on the mainstream series and the ROG series. We had a lot of users that would look at boards that say like the Deluxe or like the Extreme, and they would be like, hey, we really, really love these boards, but you know what, I'm not so focused on overclocking, right? And I don't, maybe I game, but I don't necessarily have such a key focus to have all these specialized advanced features, or maybe I don't need every single supplemental new feature that we've integrated into the mainstream series. So Tough was kind of trying to distill down and say, look, let's focus in on having a board that's really targeted at having a high level of reliability and quality. We had a lot of interest in people that wanted more advanced forms of monitoring their temperatures and their cooling and being able to manipulate that. As part of that thermal armor, right, you got those sensors on the board that do all that real-time temperature monitoring.
Okay.
And all of that even came into the vibe of how long does a person run their system, right? We talked about ROG users. They tend to fall into two camps. Either they roll over to every chipset or they buy to the long term. Sabertooth users tend to consistently be somebody that they appreciate the fact that the board comes with a 5-year warranty, right? Because they're building for a 3 or 4 or 5 year life cycle, right? They tend to buy saying, hey, I want a really solid system. I want this level of functionality. I want to know that it's going to be consistently working, and we go in that respect, right? So, they definitely, there's going to be overlap, and at the end of the day, we're honest with you guys as users. We realize that marketing exists only inside of a marketing department when it comes to the segmentation.
Right.
At the end of the day, our job is still to make sure that any one of these boards that you buy, it has an outstanding level of performance, reliability, stability, even overclockability. Every single one of these boards are going to overclock exactly the same. They won't be compromised in that regard. Now, might the ROG board have some more advanced levels to how you can achieve your overclocking? Yes, as compared to the Sabertooth board.
Okay.
But for the normal user, there's not going to be that level of clear differentiation. So then it comes into what we really want you to do, regardless of which board you buy, is buy based off of the feature set. Don't buy off of the conception that somehow you're going to get more performance from one board over the other board. And I think that's a very important point for us, because our Dash A SKU is about like a $140 motherboard. And we'll show later on overclocking. I'm going to show you 4.8 gigahertz at 2400 on that board, just like I do it on the Deluxe board. There's no difference. Now the Deluxe is going to have a heatsink that's twice as large with a heat pipe, right? So yeah, is the VRM, which also features some higher end components, going to run maybe a little bit cooler, overall have some better thermal tolerance? Yes, right? But in terms of the overall key aspects of performance and overclockability, it's going to be the same. But maybe that Dash A user doesn't need 802.11 AC built on board. They don't need Bluetooth. They don't need 10 SATA 6G ports, right? I'm happy having 6 SATA 6G ports, the USB 3. I've still got even SLI support, right? So I've got a lot of those base things that I need. So it's honing in on the board that says, what, this is what I really want when I'm building my system.
Okay. So You know, you mentioned switching between these won't really change your level of performance, and I think that's something that's been the case for several years in the motherboard market, right? It's not even inside of everybody, inside, say, ASUS's different product segments, but I'd say it's almost outside into competitors as well, right? And if you get an MSI and Gigabyte, it's something we found with motherboard reviews at PC Perspective was it's very hard to look at two motherboards, run a bunch of benchmarks, and really kind of tell you an interesting story about why they're different and why you might want one versus the other. Because at the end of the day, the 4770K running on one board versus running on another board is going to produce the same Cinebench result. It's going to produce the same 7-bench results. As long as all the settings are the same, performance differentiation is very difficult.
Yeah, I think to a relative degree, because I think that there is still definitely key points of differential. I mean, an example might be some competitors could have segmentation amongst their products, but they're not going to necessarily ensure that the continuity or the consistency in, let's say, something like the UEFI is going to be mapped across every single segmentational product. Okay. And so, you know, you're not going to get that. If you look at that Dash A board to the Deluxe to the Sabertooth to the new Maximus 6.0, they're going to be consistent across the board. There's no continuity break, right? We haven't pulled out a certain switch, or we haven't, you know, made something apply less. Even things like the UEFI updating regularity, right? Whether it's a premium product or whether it's that more entry-level product, we're still committing ourselves to be consistent. But I definitely agree that, you know, in the reality of the way the architecture has been designed by Intel, the more that we've integrated inside of the CPU package, you know, whether it's things like the memory controller, now even with the IVR, you're allowing to have more continuity and consistency within how the performance of the architecture works, and even to some extent, right, how overclocking can work. Where the differentiation is going to come into play is going to be in those experiential aspects, right? Whether it's in layout, physical aspects, whether it's going to be in the connectivity or the feature set and the software, the UEFI, compatibility, and those type of things. So there's still quite a bit this differentiation, but like you said, at least from an end user perspective, performance, you can help to feel that there's that sense of continuity and consistency between a lot of products.
All right. We're going to, one quick note here for people who are watching the live stream or trying to fill out that form. You may have to be a registered user on the website, pcper.com, in order for that to work. Where for some reason, a lot of submissions are showing the IP address of 127.0.0.1, which is obviously an internal server caching issue. But if you're a registered user, that does not appear to be an issue. So go ahead and register on the site, fill out the form, and you can win the Z87 Sabertooth. Moving on, we talked about consistent design consistency on the boards, right? So let's talk about some of the features that do find their way onto all four of these different segments of motherboards, and thus onto most, if not all, of the Z87 lineup. Yeah.
So definitely, I mean, that's one of the things that we definitely pride ourselves as a vendor. And even though right here, you know, we've got probably more of the higher end base boards that within our product portfolio, this is going to, like I said, apply through a large amount of what we have as an entire Z87 kind of board stack. So, you know, one example might be something, let's say, like the fan control functionality. You know, we've talked about this in the past, where we really pride ourselves on integrating this type of design where, you know, you don't want to look at a product from just a spec-based perspective. If you look at it from purely a spec-based perspective, so let's say you go to your favorite e-tailer, or you go to the, you know, brick and mortar location, and you take a look at the box, and one board says 5 fan headers, and this one says 5 fan headers. That doesn't tell you how those fan headers actually work, right? You know, a perfect example is this. In this chassis, I've got 1, 2, 3, 4, 5, 6 total fans inside this system, and with our motherboards, we have the ability to control every single one of those headers uniquely. So we can go inside that UEFI, we can go inside the software environment, and we can tune them. Whether it's a 3-pin fan or whether it's a 4-pin fan, it doesn't even matter. Even some really cool updates for this generation, like, I don't know if you'll be able to show them, but for the CPU primary header for this generation, we even incorporated a new little design where it's going to be, it's actually, I think, closer right over here.
Over here. Yeah.
Okay. So the primary CPU fan header, it's probably a little bit hard for you guys to see, but inside there's an actual depression switch inside of it. So you can probably see it right next there to the 4 pins for the fan itself.
Yeah, it's hard to see there. Yeah.
And that little header, the cool thing about it is that it'll automatically sense essentially whether you've inserted a 3-pin or DC-based fan or 4-pin PWM-based fan, because of course they get tuned and they get calibrated differently, right?
Gotcha.
And so the user wouldn't even have to make that adjustment. It's a small attention to detail outside of the fact that every single one of the headers is fully controllable, right? But that's on every single one of these boards. It's not like it's just on the Extreme board. And that's something that we're prideful at, because you could go all the way down to our Z87-A, once again, so an entry-level SKU, or the Plus SKU, or the Griffin, the Micro ATX SKU, and all of those are going to have that Fan Expert 2 technology, right?
Okay.
So that's a great, consistent, let's say, design feature.
Yeah.
Another one might be something like, our USB 3 boost technology. In the past, we've talked about how USB, the bus itself, uses preset forms of protocols for transmission of speeds. There's BOT protocols, there's SCSI protocols, and there's optimally UASP protocols. So we have a hardware and software implementation that allows us to optimize the actual protocol performance for flash and for different types of external storage devices where we can improve the performance. That's going to be on every single one of these boards. Another one might be something like USB Charger Plus. A lot of us right now, we're definitely taking on more and more types of mobile products, whether they're things like smartphones or tablets, right? And, we have great designs on the boards that allow you to quick charge these devices. It's not just limited to iOS-based devices. What happens if you got an Android-based smartphone, or you're like me, I just got, brand new Nokia 928-based phone, right? We can quick charge any one of those, or it could be an e-reader, whether the system's on sleep, hibernation, or even off, it doesn't matter. That's going to be a hardware spec that's going to be built in there. Intel NICs, that's another thing that, we feel that the performance, the compatibility, the management options that you offer with that caliber of network controller, it's better. It's going to be on pretty much the majority of the SKUs, I think, all the way down to our Z87 Plus board. So not the Dash A, but the Plus, one bump above, which is still about like a $160 board, and all the way above every single one of those are going to be Intel NICs. And that's before you even get to maybe some real of the design initiative points. For this generation, if I can bring up maybe actually a little slide here to kind of show you something. Okay. We haven't really been a company that's focused a huge amount on calling out like component design quality. We've, I feel, been, a company that we've relied on the fact that year after year we've generally shown ourselves as being the #1 board vendor in terms of sales globally, to say, hey, our position is justified by the quality that we have in our product. But for this generation, we're trying to give some more messaging onto some of the inherent design points that are built into every single one of our boards regardless. So part of this comes into a new kind of messaging that we call 5X protection. And this comes through into different ways. So, one of them could be, we've in the past for years now been messaging digital power design. And we still continue to offer digital power implementation. Now, this is a little bit different because, of course, this generation Intel has the fiber built on board. So technically every company to a degree has digital power. But our experience with working with the digital implementation has allowed us to really optimize and know what type of switches, what type of options inside the UEFI make it really easy to work with. Plus, you still actually need an external PWM to translate the PSU's essentially input to the fiber. So it's unlike actually previous generations where it was only a one stage from your PSU to the PWM and CPU. It's actually a two-stage hop now, which is kind of interesting because it changes the efficiency. But we also then still have a digital controller for the DRAM, which is required. So we still give you this robust level of control and manipulation and management functionality. Or things like we have special design implementations where there's an overprotection circuit that's built onto every single one of the DRAM. And that's important because let's say if you get like a surge or a spike or a sag, something that comes through the board, it could compromise, sit through the memory, it could damage the memory, it could affect other parts of the bus. It's built onto the board. Our capacitors, for a long time, I think now for almost like 3.5 years, almost 4 years, we've, on the majority of almost 90% of our boards, been using 5K rated capacitors versus the industry standards 2K rated capacitors. So these are stuff, in the past, we've never really even talked about them. They've just been there. You've just already had these type of design initiatives, and this is what we mean by non-negotiable. There's going to be stuff like this that inherently adds to the quality of the product regardless, but you're also going to get a lot of real value-added features, like I said, so advanced stuff like Fan Expert 2, all the way down to something just like capacitors that are rated for twice as long as what the address is. Even things like the actual I/O shield and the actual brackets that are composed of our units, we actually use a stainless steel stainless steel for the actual metallurgy, and then we actually have a special coating that we put on them. It minimizes the oxidization that even occurs to the housing assembly, because what we've noticed is in different environments that have different ambience, the actual inside can become oxidized and it can affect sometimes the inside contacts. So things like USB ports or things like that sometimes can act a little bit wonky over a long period of time if you're in a really hot or ambient environment. We're the only company that does that. Every other company uses a much cheaper carbon-based plating mechanism. It saves a little bit of dollar in the production process, like $1, but it's like I said, little things like that. What we mean design consistency is that we really feel that regardless of which board you're going to buy from us, you're going to get a really solid product, but you're also probably going to get a lot more functionality. So always try to just look past what's that initial first specification and look at more what exists in the product. And I think that's hopefully what you guys do when we work with you guys from a review standpoint, is that, you know, that additional layers being looked at, you know, whether it's the UEFI, whether it's the fan control functionality, whether it's those
one of the things
deeper things.
You know, one of the things that we really appreciate on our side is the fact that because it is consistent from every board, like it's not like we need to re-explain a lot of these things. You know, when we talk about a $160 motherboard versus when we talk about a $280 or $290, $300 motherboard, we can say, you know, these same things exist all the way down the line, and they exist in much the same form factor or much the same function. You know, we'll talk about the fuses and the 5K caps and that kind of stuff. And it's really nice to be able to know that inherently when you're looking at lower end product. Maybe not lower end, but lower priced product.
And I think that's a great way to look at it, because we don't view it as, I mean, it's lower in price, but we don't perceive it to be lower in quality, right? It's a question that the value, a lot of times the word value gets thrown to be something that's only cheap, and we think you can actually pay a large amount of money for something and have it be a horrible value, and you can actually pay a low amount of money for something and actually still have it be a poor value. You know, value really comes across as that whatever price banding you're paying, whether it's a $150 board, a $200 board, or a $300 plus motherboard, is what am I really getting out the total experience of the product, whether it's in the feature set, the functionality, the usability of the product, that's going to define whether the money you've spent on it is actually justified.
Very good. All right, so now our next step here in our live stream, JJ, is going to be a lineup overview.
Yeah.
Now, in order for us to do this, we need to resituate our desktop environment.
We do. We're about to bring a whole lot of boards out.
Because we're going to bring out a whole lot of motherboards. So if you're watching the live stream, stick with us. We are going to mute our microphones so you don't get any issues with that. We're going to stack a bunch of stuff on this board, and then we'll talk about them individually. So stick with us. We'll be right back.